Hey everyone, and welcome back to the channel. Are you tired of slow databases that make your applications crawl? Do you want to unlock lightning-fast data retrieval and boost your system's performance? Then you're in the right place. Today, we're diving deep into how to improve database performance. This awesome infographic lays out some key strategies you can use to supercharge your database. We're going to break down each of these techniques in plain English, so you can understand exactly how they work and how to apply them. Let's start with partitioning. Imagine having a massive library with all the books piled in one giant room. Finding a specific book would take forever, right? Partitioning is like dividing that library into smaller sections based on categories or dates. In database terms, we divide large tables into smaller, more manageable pieces. This makes queries faster and maintenance much easier because you're only dealing with smaller chunks of data. Next up, we have query optimization. Think of your database queries as asking the library for a specific book. A poorly written query is like giving very vague and inefficient instructions, making the librarian, your database, search through everything. Query optimization is about revising and adjusting your queries to be more precise and efficient, leading to much faster execution times. Tools and techniques can help you analyze and rewrite your queries for optimal performance. Now, let's talk about denormalization. You might have heard about database normalization, which aims to reduce redundancy. Denormalization, on the other hand, intentionally adds some redundancy to simplify the data structure and reduce the need for complex joins during querying. For example, instead of always joining customers and orders tables to get the customer's name, you might include the customer's name directly in the orders table for faster retrieval in certain scenarios. However, be careful with denormalization as it can lead to data inconsistencies if not managed properly. Here we have replication. Imagine having multiple copies of your important documents in different locations. If one copy is unavailable, you can still access the others. Database replication involves creating multiple copies, replicas, of your primary database across different servers. This not only balances the read requests, distributing the load, but also significantly improves availability. If the primary database fails, one of the replicas can take over. Let's look at sharding. This is like taking our giant library and splitting it into completely separate, smaller libraries, each containing a subset of the books. In database sharding, we break down a large database into smaller, independent segments, shards, distributed across multiple servers. Each shard contains a portion of the data, allowing for parallel processing and significantly enhanced performance and scalability for very large datasets. Next, we have database caching. Think of it like keeping the books you frequently need on a nearby desk instead of always going back to the shelves. Database caching involves storing frequently accessed data in faster storage, like memory, that's closer to your application. This alleviates the load on the main database, as the application can retrieve the data much quicker from the cache. Now, let's talk about index creation. Back to our library analogy, an index is like the index at the back of a book. Instead of reading the entire book to find a specific topic, you can just look it up in the index and jump directly to the relevant pages. In databases, indexes are special data structures that allow the database to quickly locate specific rows in a table based on certain columns, dramatically speeding up data retrieval. However, too many indexes can slow down write operations, so it's about finding the right balance. Here we have materialized views. Imagine pre-calculating the answers to common complex questions and writing them down so you don't have to figure them out every time. Materialized views are like saving the results of pre-calculated queries. For complex, repetitive queries, instead of running them every time, you can store the results in a materialized view, which is updated periodically. This significantly speeds up retrieval for those specific queries. Finally, let's discuss vertical scaling. This is like upgrading your existing library building to be bigger and better, adding more shelves, more librarians, and faster systems within the same location. In database terms, vertical scaling means expanding the capacity of your existing database server by adding more resources like CPU power, memory, RAM, or storage. This can improve performance, but it has limitations as you can only scale up to the maximum capacity of a single machine. So, there you have it. 9 key strategies to significantly improve your database performance. From breaking down large tables with partitioning and sharding to optimizing your queries and leveraging caching and indexes, each of these techniques plays a crucial role in creating faster and more efficient database systems. Implementing even a few of these strategies can make a huge difference in your application's speed and responsiveness. Remember to analyze your specific database workload and choose the techniques that best fit your needs. Which of these database performance improvement techniques are you most interested in trying? Let me know in the comments below. If you found this video helpful, give it a thumbs up and don't forget to subscribe for more tech tips and explanations. Thanks for watching, and I'll see you in the next video.